In example 6, we want to perform the indicated operation, and then we'll find also the magnitude of the resultant vector. So we'll work on this one first, and then we'll try to find the magnitude of the resultant vector. We're also given some information here with vector v and vector w. So if we look at part A, we want to write down v minus w, and we'll just set this equal to, vector, we'll go vector r here. So vector r then is going to be vector v, which is 2, -4, 5, minus vector w, which is 6, -8, and 9. So to accomplish this task, we're just going to do the subtraction with the x, y, and z components separately. So 2 minus 6 is -4. -4 minus -8 is +4. And then 5 minus 9 is -4. So there's your first resultant vector for part A. We want to find the magnitude of that vector here. So try to draw that vector symbol a little better. And to do that, we're just going to take the square root of each one of the components squared. And then, of course, we want to add those components together before we do the square root here. So let's see what that works out to be. I think we're going to have 3/16 to add up underneath, which is 48. And then we can simplify this. So just like we said before, that was 3/16 or 16 times 3. And the square root of 16 is 4. The square root of 3 is just the square root of 3. So in fully rationalized form, there's your magnitude for the resultant vector. Let's work with the next one. So we've got 5 times v minus 2 times w. We'll make that equal to vector s just to simplify things a little bit. So vector s will be 5 times 2 times -4 times 5 minus 2. And then we've got vector w here, which is 6, -8, 9. So we want to do that multiplication piece first. That's those scalar multiples. So we've got 10, -20, 25. And then we're going to actually multiply -2 by each component on the right-hand side for vector w. So this will be -12, 16, and -18. Then we'll just add the x, y, and z components separately. So 10 minus 12 is -2, looking at your x components of each one. Then we've got -20 plus 16 for your y components, which is -4. And your z components will be 25 plus -18, which happens to be 7. And once again, to find the magnitude of that resultant vector, we're just going to take the square root of the x, y, and z components squared and then add it together. And we'll do that square root last. Oops, that should be a 2. Scroll up a little bit. So we've got 4 plus 16 plus 49, which is the square root of 69, which I don't believe can be broken down any further. We could represent that as 3 times, let's see here, that would be 23. 23 is prime, so is 3. So square root of 69 will stay as our magnitude.